Module 1, Thermodynamics. What does thermodynamics mean? Thermo, it is nothing but a temperature or a heat, and dynamics, nothing but the changes of it. Or in short, we can say thermodynamics is nothing but analysis of a temperature or a behavior of a heat, which we are going to see. Before starting here, we want to clear that what is the difference between heat as well as temperature. Heat is nothing but form of energy and temperature is measure of energy. Initially, if we start talking about thermodynamic properties, so what are these thermodynamic properties? This is nothing but it defines the characteristics of a system. So what are the properties of a system? So if we see, before going to that, we can call what is a system. So what is the system? System is nothing but in the entire universe where we are focusing to check on a matter or in a place or in a thing or in an object where we are doing a thermodynamic analysis in the entire universe. That is nothing but called as a system. Or for example, if I am taking a cup of tea, so when I initially take a cup of tea, the tea will be having some temperature. After a few minutes, what will be happening? The temperature of tea will be reduced. So what was happened? There is some sort of heat flow has been happened or heat transfer has been happened. So how it was happened? If I want to study, then in that case, what will be the tea is called? Tea is called as my system, and where it has been holding, it was been holding within a cup. So then the cup will be called as a boundary, and the tea is surrounded by a boundary, and after the boundary we are having a surroundings. So here we will call the cup as a boundary and surroundings as a surrounding and tea as a system. And here now if I want to talk about properties of a system, here it will be having can classify it broadly into two types. One is extensive properties and second is intensive properties. The extensive properties are nothing but which depends on the mass, of a system. Those we will be calling it as extensive properties, and the properties which are independent of a mass, then we will be calling them as intensive properties. If I take extensive properties, there is nothing but which are depending on the mass, or for example a volume, mass, size, weight, length, and all this we will be calling as extensive properties. If I talk about intensive properties, these are nothing but these are independent of the mass. For example, the temperature, color, hardness, and density. This all comes under intensive properties. And here if I see basic concepts of thermodynamics, it is nothing but here these are nothing but called as terminology which we are using it in the thermodynamics. The first one is state of system. What is the state of system refers to? The state of system refers to what's the properties of a system, whether it may be temperature, whether it may be a weight or a color or all these properties of a system we will be calling it as a state of system, especially in the thermodynamics. So the state of system refers to properties of system. It doesn't refers to whether liquid phase state or solid state or not, that one. It refers to properties of system. And next, if I take a thermodynamic process, here it can be classified into a reversible process or irreversible process. The reversible process is nothing but, as the name indicates, it can come back to an original position. It will be in an original position. It is moving to a different position or in a shape with the help of a temperature or a heat energy, and again if we are supplying the same amount of heat energy, it can be regain its original position. That is nothing but called as a reversible process. But in case of irreversible process, in here also, to go from one shape to another shape, it requires again a heat energy, but again if we are supplying the same amount of heat energy, it cannot come back to an original position. The best examples are if you are taking a metal and if you are doing a casting process, by applying a heat, it will be coming from a solid state to a liquid state, and from the liquid state we can do it whatever the shape it is required. and again if we want to get back into an original shape, again we can melt those things and we can get back into an original shape. So but in case of irreversible process, as here it indicates from the egg to an omelette, it is not, it is an irreversible process. We cannot get back from an again omelette to an egg. It's for an easy of an understanding. And here if I talk about a thermodynamic cycle, thermodynamic cycle, it is nothing but a series of steps are taking place, and again it is coming back into an original position, or it is happening it in a repetitively. For example, if you take in a process in your refrigerator, so what will be happening? From a vapor it will be taking the heat, and again it will be sending it to an outside, and again coming it, and again the refrigerator is working it in a continuously. So there it is nothing but it is happening in a cyclic way. That is nothing but called as a thermodynamic cycle. And internal energy, it is nothing but what is the amount of an energy it is present inside the system, or we can call it as a sum of potential energy plus kinetic energy. So if I am summing of a potential energy and a kinetic energy, that is nothing but called as an internal energy, and we will be representing it with a capital U. Enthalpy. What is an enthalpy? Enthalpy is nothing but the amount of a heat energy present inside the system, or it's a amount of a total energy, or we can call it as a sum of internal energy plus product of pressure into volume. Enthalpy is equal to U plus PV. U is nothing but internal energy, PV is nothing but pressure into volume. So sum of internal energy plus product of pressure into volume. Entropy. What is an entropy? Entropy is nothing but it's the amount of energy present inside the system, but it is not useful to do any work, or the amount of energy which is present, it is not good for doing of any useful work, or you can call it as a loss, or you can call it as a randomness. That is nothing but it's called as an entropy. If we take a thermodynamic systems, we are having three types of systems. First one is open system, second is closed, and third is isolated system. In case of an open system, what is going to be happen? There is a change in energy as well as in a mass. Both are going to be changed. That is nothing but called as an open system. But in case of a closed system, the amount of heat energy can go out or come in, but mass cannot be changed. So that is nothing but called as a closed system. If there is no change in the either mass or an energy, in that case we will be calling it as an isolated system. Next topic is heat energy. What is heat energy? Heat energy, it is nothing but it is defined as a transfer of energy without transfer of mass. So here what is happening? This transfer of energy is happening, but the mass is not getting transferred. So here if you take for example a boiler, what will be happening inside a boiler? Inside the boiler, the temperature will be raised. The temperature will be raised, and so if I take in a condenser, in case of condenser, what will be happening? There will be a drop in temperature, or temperature is going outside the system. So if I take here, in case of a boiler, the temperature is coming inside. If temperature is coming inside or a heat is coming inside, the temperature will be raised. If I take in a condenser, what will be happening? The heat energy is going out, or there will be a reduction in temperature, or a reduce in temperature. And generally heat is transferred from a higher temperature body to a lower temperature of body. So there is nothing but if you are keeping in a hot body and in a cold body, normally the heat will be transferred from a hot body to cold body. The next topic is work. What does the work refers to? Work refers to an energy transfer between the system and its surroundings, and whose sole effect on things of external system can be converted into raising of a weight. Or for a simple understanding, if you are having a cylinder, inside the cylinder we are having a gas and we have kept a lid. On top of that we have kept in some weight. What will be happening? Due to the amount of weight, the gas will be getting compressed. So now once it is compressed, what we are doing, if we supply an amount of heat energy, if we supply a heat energy, what will be happening to a gas? The gas molecules will be getting expansion, or the pressure inside it will be getting raised. So what will be happening if the pressure is increased? It will be trying to push the lid to the up, but what is happening with the due to the weight, it is pushing down. So once after a certain time, once it gains enough amount of pressure energy, it will be pushing the mass to up, or lifting the weight to up. This is nothing but called as work. So here, if the system is raising the weight, or system is performing the work, this is nothing but we will be calling work done by the system. Or in the second case, after some time we are not supplying any heat energy, so what will be happening? Slowly the temperature inside the system will be getting down. So at that time the pressure inside will be getting reduced, and whatever the amount of weight it is there, it remains in a constant. So what will be happening? The opposition force will be happening, the weight will be pushing the lid down. At that time what will be happening? Again it will be coming back to its original position. At this time what is happened? Due to the amount of weight, the compression is happened, or work is done on the system. So here the work is done by the system in the first case, and in the second case work is done on the system. So when it is raised, work is done by the system. When it is getting compressed, work is done on the system. If you observe in these cases, in both the cases, the boundary has been getting changed.
Heat and work sign conventions. So here, if we are assuming this as a system, if the Q, which is in a capital Q, refers for a heat energy. If heat is gaining by the system, then we will be representing it as a positive heat energy. And if heat is lost by system, surroundings is gaining the heat energy, then we will call it as a negative heat. And when coming to a work we represent with a capital W. If work is done by the system, then we will take it as a positive W. If work is done on the system, then we will be considering it as a negative W. Laws of thermodynamics. Here we are having four laws, which means the zeroth law of thermodynamics, first law of thermodynamics, second law of thermodynamics, and third law of thermodynamics. If we say zeroth law of thermodynamics, so here zeroth law states that here we consider A, B, C as a systems, and if A and B are in thermal equilibrium and A and C are in thermal equilibrium, then we can say that B and C are also in thermal equilibrium. What this says, if A equal to B and A equal to C, then we can call B is equal to C. That is nothing but Zeroth law of thermodynamics. What are this ABC? ABC are nothing but systems. The equal to will be representing with an equilibrium. To be specifically thermal equilibrium. First law of thermodynamics. What does first law of thermodynamics states? The first law states that when a closed system undergoes for a thermodynamic cycle, the first law says that the net heat transfer is equal to the net work transfer. Or in other ways, we can say that it is a law of conservation of energy. Whatever is amount of heat transfer is done, that is equal to the same amount of work is going to be done. And here we'll be getting an equation of delta E is equal to Q minus W. What is the Q? Q refers for heat energy, and heat transfer. W refers for work done. Second law of thermodynamics. The second law of thermodynamics has been defined by two people. One is Kelvin Planck statement we will be having. The second is Clausius statement we are having. According to the Kelvin Planck, it is not possible to construct an engine working in a cyclic process whose purpose is to convert energy from single thermal reservoir into an equal amount of work. Or What does it say? Because it's impossible for a system or the machine to convert a complete amount of heat energy into an amount of work. So here we cannot convert a complete amount of heat transfer into a work. So where does it is going? It's nothing but it will be going as an entropy or an losses. Or it says that there is an always degradation of a loss of energy. Second law of thermodynamics stated by a Clausius statement. What is Clausius statement? It is nothing but normally we all know that if we are having a hot body and a cold body, how the heat is going to be transferred? Yes, it is transferred from a hot body to a cold body naturally. But if it has to transfer from a cold body to hot body or in a reverse way, what it has to be there? There we have to have some sort of an external aid or an external energy or an external work need to be done. It requires some sort of an energy. So for example, if heat found to transfer from a cold body to hot body, in that case we require some external amount of energy. And the best example is nothing but our refrigerator or an AC. If you take refrigerator as a system, inside the refrigerator we will be having a lower temperatures and surroundings will be having more temperatures. But if you open the door and if you are keeping again and again also, what will be happening? The inside temperature will be consistently maintained low. Till when? Till it is plugged into an electricity or there is an electrical energy. So that what is an external aid? Here the external aid is an electrical energy which we are getting here to maintain the cold body into a still further cold. Next is third law of thermodynamics. What does third law of thermodynamics says? The third law of thermodynamics says that absolute zero temperature, the entropy will be zero. So what's entropy? Loss. So what does it say? At an absolute zero temperature, the entropy will be zero. What is an absolute zero temperature? Absolute zero temperature is nothing but it's in a minus 273 degrees centigrade. And this absolute zero temperature is only a theoretical concept which cannot be achieved practically. So, what is this then? What does third law says? Third law of thermodynamics says? It says that if you are approaching towards to the absolute zero temperature, if you are approaching near to the absolute zero temperature, at the time what will be happening? The entropy will be tending to zero. So, if you are approaching towards the absolute zero temperature, the entropy will be tending to zero. If you are reaching to an absolute zero, then entropy will be zero. That's what is in a third law of thermodynamics. Thank you guys.